In this video, I want to have a look at using Pythagoras' theorem to solve practical or worded problems. So if we're given Pythagoras' theorem problem, we should always draw a diagram if it's not already given to you, because it helps you get everything clear in your head. So let's have a look at some examples. So our first question says that a 4-meter ladder is leaning up against a wall. The foot of the ladder is 1.8 meters out from the base of the wall, and we're asked to figure out how far up the wall the ladder reaches. So if we're drawing a diagram, we've got, that's not a very straight line. We've got a wall here, and we're imagining that's a perfectly straight line. And we've got a ladder leaning up against the wall. And we know that that's how far away from the base it is. So that's going to make a right angle. It tells us that our ladder is 4 meters long. And it tells us that the foot of the ladder is 1.8 meters away from the base of the wall. So this is the base of the wall, and this over here is the foot of the ladder. So that's going to be 1.8 meters. I'm just going to get rid of this bit of wall that's up the top that we don't need. And then we're asked how far up the wall the ladder reaches. So we want to figure out how high that point is there that's at the top of our ladder. So we're trying to find this height here. So you're going to give that a letter, and it doesn't matter what letter it is. It can be H for height, it can be X, because that's a variable that we use quite often. I'm going to use H for this one, but it's up to you. And then we can use Pythagoras' theorem. So because we're trying to find a short side, I'm going to write this as H squared is going to be equal to my hypotenuse squared, so my 4 squared, minus the other short side squared. And then I'm going to pop that in my calculator. So from your calculator, when we put that in, we're going to end up with 12.76. And then we have to square root that to find out what H is. So we'll square root 12.76. And it hasn't asked us, but for this one, I'm going to round to 2 decimal places. So that would give us 3.57 meters, and that's 2 decimal places. Now, the other thing with practical or worded problems is always to check whether your answer is reasonable. So if we've got a 4-meter ladder, it's 1.8 meters out, 3.75 for that height makes sense. But if you got a number like 12.76 and you'd forgotten to square root it, you'd know that's wrong because there's no possible way that a 4-meter ladder can reach 12 meters up the wall. So always check whether your answer is reasonable. Our second example isn't technically a practical problem. It's not even really a worded problem, but it is a more complicated Pythagoras' theorem problem that you might get. So we're going to have a look at it. So we're asked to find the length of this side here. Now what they've got at the moment is a trapezium, and they've drawn this dotted line down here, and that's broken our shape up into a rectangle and a triangle. So I want to just focus on this triangle. So I'm going to redraw the triangle part out here. And this is our K here, and we've got a right angle. Now this side length here has to be equivalent to this side length here. They have to be the same length because they're opposite sides of a rectangle. So if this one here is 9 meters, then our side length, this one along here, would be 9 meters as well. Now we've got to find the base. So we know that the whole base all the way from here to here is 48 meters. And we're also told that this part here is 8 meters. So that means from here across to here is 8 meters, but the whole thing altogether had to be 48. So to figure out what this section is, which is the base of our triangle, we do 48 minus 8, which would give us 40. So we're going to have 40 meters along the bottom and 9 meters up the side. So then we've got our triangle with our measurements on it, and we can find K using Pythagoras' theorem. So we know Pythagoras' theorem is c squared equals a squared plus b squared. And we are finding the hypotenuse. So in this one, we're going to have k squared is equal to 40 squared plus 9 squared, which we can then put in our calculator. So 40 squared plus 9 squared would give us 1,681. And then to find k, we're going to take the square root of that number, which would give us a really nice whole number, 41. Again, check the reasonableness of that. We've got a side length of 9, a side length of 40, and a hypotenuse of 41. So that does make sense because it's pretty close to the 40. It's somewhere in there. And it does have to be a bit longer than the other sides as well because it's the hypotenuse. So that's having a look at some more complicated problems involving Pythagoras' theorem.